In our third lesson in Unit 4, we're going to focus on a couple shortcuts for proving triangles congruent. The goal here is to shorten our proofs substantially, hopefully. Thus far, when proving triangles congruent, we have had to show that all three pairs of sides, of corresponding sides are congruent, all three pairs of corresponding angles are congruent, and then we needed a seventh step to state that the triangles were congruent. So our proofs were just long. And what we're going to find out here is that through the application of some rigid motions, we can determine that there are a few shortcuts that we can take. And so today, in this first video for 4.3, we're going to chat about two shortcuts in particular, SAS and SSS. In the subsequent unit, we'll do ASA and AAS. We're going to tell you what those abbreviations mean as we get there. So our goal is to use these two shortcuts for proving triangles congruent, and hopefully this goes well for you. The side angle side, that's what the SAS stands for, side angle side congruence shortcut, basically says if we have two pairs of sides between these two triangles, along with the angle that's included between them, all congruent to each other, then we can say definitively that these triangles are congruent. And so we can use this as a shortcut to basically say if we've got this angle along with these certain distances for the lengths of sides, then the only way that I can fit a third side is if it is the same length as this other one, and at the same angle measure as we would determine in these other situations. And so, if two sides in the included angle of one triangle are congruent to two sides in the included angle of the other triangle, then those two triangles are congruent. What this means for you and me is that instead of having 6 pairs of corresponding congruent parts plus the congruent statement of the triangle, we can simply have 2 pairs of corresponding congruent sides along with the included angle pair congruent, which means that there's only 3 statements here plus the 4th one for the triangle congruent statement. So it significantly reduces the length of our proof. Now, before we move on, let's make sure that we understand what I mean when I say the included angle. Hopefully you can tell that I'm talking about 2 sides and the angle that is formed by those 2 sides. That's what I mean by the included angle. All right? So over here in this situation, I've got 2 sides marked. The included angle would be, say it together with me, angle J. Yes, correct. Angle J is the included angle between the marked sides JH and JK. Now, a quick little shortcut, a little tip or trick, if you're curious, is if we have JH and JK, then J is the included angle. All right? Or at least J is the vertex. If we have multiple angles at point J, then we'll know that the angle at J for this triangle, KJH or HJK, is the correct angle that is included between the marked sides. Over in this next one, we see these markings here, EC and ED, which means that the angle at E is the included angle between those 2 sides. All right, being able to identify that just sort of helps expedite the proof process. If you know, ooh, I want to use side angle side here, I have to make sure that I got that angle in between those given sides. All right. This is a little shortcut that actually, the reason why it's here right now, I'm not entirely sure why, all right? This is something that I would include after we do all 4 of our shortcuts. This is basically another way to state that when you have congruent triangles, then you know all of the corresponding parts are congruent. We just did that in lesson 1, all right? So this is not news. This is just another way to say that if we are having congruent triangles, then we can state that the corresponding parts of congruent triangles are congruent to each other. All right? So we have stated before, given all this information, we know that triangles are congruent, but we've also been using the fact that if the triangles are congruent, then we know all their parts are congruent. And so you can use the definition of congruent triangles if we are supposed to be using CPCTC in a proof, but we can just abbreviate this definition as CPCTC if you don't want to write definition of congruent triangles. Sorry for that non sequitur. I know it seems a little bit random. This is theorem 4.4. The last one was theorem 4.3, and now we're going to have theorem 4.5. So I apologize for the way that the book does this, kind of seemingly out of order. We will deal with CPCTC the week before Thanksgiving, so hang tight there. So side, side, side is another triangle congruence shortcut. Basically, if all three pairs of sides are congruent to each other, we do not have to worry about the angles at all. We will know, if all three pairs of sides are congruent, that there's only one way in which that triangle can be formed, and it's going to be formed with those respective angles. And therefore, all the corresponding parts would be congruent. So, if we have three pairs of corresponding sides congruent, then we do know that we have two congruent triangles. All right? And we can use that in a proof as we're going to explore here momentarily. So we're going to do a handful of proofs. Again, I know that you're hesitant and reluctant to enjoy these, but the repetition is going to build in a little bit of confidence, and you will see how much shorter these proofs are than the ones that we have done. This is a pretty complex proof, and so forgive me if this is a little bit more than we can chew, but I'm going to give this a shot. JK and LM bisect each other, all right? So think about that. They bisect each other, which means if we want to read this sentence in two different ways, JK bisects LM and LM bisects JK. So reading that sentence and understanding what it means is obviously critical to being able to do this proof, but seeing it on the picture, if JK bisects LM, then that means that these two pieces are congruent to each other. That would be the definition of bisect. If JK is bisecting LM, we know that this is true. Furthermore, if LM bisects JK, then that means that this segment is cutting this one in half into two congruent parts. We will use that definition of bisect twice. Furthermore, we know that we have a pair of vertical angles. That's one of those freebies, all right? We should be able to see, ooh, we've got a pair of vertical angles around point P. That's my free information. So we're going to use that information to make a side angle side triangle congruence proof. Notice how I thought all the steps out before I wrote them out. One tip that you can use is instead of just word vomiting out onto a paper for a proof, start thinking through how you might structure it. All right, that's going to be the best approach to doing geometric proof. Now, sometimes if you're totally stuck, just start spitting out the given information and see where you can go from there. But here we know that JK and LM bisect each other means two different things. It means that JK bisects LM, which means that PM and PL are congruent to each other. Also, this sentence can be read in reverse, that ML bisects JK. Also given, I just separated that into two thoughts instead of one, which means that JP and KP are congruent to each other. All right, so that's the markings for the sides. Now, I also know that the angles around P are vertical angles. So angle JPM and KPL are congruent by the vertical angles theorem. You can either write vertical angles theorem, you can write theorem 1-1, which I wouldn't expect you to remember, or you can say vertical angles are congruent. All right, there's a couple of different ways that you can articulate that. If we have a pair of sides, a pair of angles, and a pair of sides, or two pairs of sides in the included angle, then I know that the triangles are congruent. I can copy this statement down right here, so I don't need to worry about the order of the letters. And I can copy that down and know that I'm using side, angle, side. Two pairs of sides in the included angle. All right. Now, as I said, we could do this a couple different ways. For example, I took this sentence and I broke it down into two. What if we put these four lines as just two lines? All right. What if I said JK and LM bisect each other? That means that PM and PL are congruent, JP and KP are congruent by the definition of bisect. Instead of having four lines that say that same thing, using that given statement twice and the definition of bisect twice, we can do it once each. All right? Then use the vertical angles theorem, and then state that the triangles are congruent. So you can sometimes write proofs in different ways, and they're still correct. Even though one person did it in 4 steps and another person did it in 6 steps, it still works out, all right, for both parties. It just depends on how you need to break that down into in a manner that you can understand and that you can also verbalize. You need to be able to write out these statements and reasons. All right, here's another proof. Let's look through these. Here, this is already marked for us. I love when the pictures come pre-marked. It's helpful. These markings mean, these hash marks mean that these sides are congruent, and these hash marks mean that those sides are congruent. So it's not stated given LM is congruent to NP and segment MN is congruent to segment PL. It's not written out for us. It's given in the figure. So we're going to make those statements that ML and PN are congruent because it's given in the figure, that MN and PL are congruent because it's given, again, in the figure, not explicitly stated, but explicitly detailed in the picture. We also know that LN and NL are the same segment, all right? So we can use that reflexive property of congruence to say that I've got this third side that is congruent to itself, and it's a shared side in both of these triangles, which means that I have congruent triangles by the side, side, side shortcut. So what I want for you to understand here, and what I want you to see here, is that it is shorter, it is much easier for us to prove that these triangles are congruent just by naming the congruent sides, and not having to name all the congruent sides and have to somehow prove all the angles congruent as well, or all the corresponding angles. So it's important that we're able to take these shortcuts. So if you are able to utilize the shortcuts, then use them. It'll be very rare that we have all 6 pieces of information. Our job is going to be able to find 3 pieces of information and work from there. All right? Thinking about these situations, go ahead and draw these pictures to the best of your ability, and also note whether or not these triangles are congruent. You should be able to tell if all 3 pairs of corresponding sides are congruent, or all 3 pairs of sides are congruent, then yes, these triangles are congruent by side, side, side. If we have 2 pairs of sides and the angle included between them congruent, then that means that we have side angle side congruence. If we have an angle and then 2 pairs of sides, or 2 pairs of sides but not the angle that's included between them, that is not going to work for us. We do not have a shortcut for SSA, for side side angle, or don't write that backwards. We're no bad words in math class, right? And then here we have, again, 2 pairs of sides and the included angle between those pairs of sides. We can be confident, even if we're having trouble understanding the orientation of the rotation or the reflection or the translation, if we're having trouble visualizing that, we can be confident that if we have 2 pairs of sides congruent and the included angles congruent, those triangles are congruent. We can trust that. We can believe that. Speaking of ascertaining that information and whether or not we can go forward with that proof, maybe think in this context, all right? In each of these pictures, there's not enough information to prove that these triangles are congruent, all right? But what I want for you to consider is what other information would you need, all right, to show by side, 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 or by side angle side that we can do this. So here's why this is important. Sometimes the information is there and we aren't seeing it. And so being able to pause and say, all right, I have this, what else would I need for side, side, side? I would need these sides congruent. Are they congruent? Can I prove that they're congruent? Is there other information I can use, like a midpoint or a bisect or something else? I need this pair of angles. Do I have any parallel lines so I can use, the alternate interior angles theorem or the corresponding angles theorem? And so you want to be able to look at the picture and say, what else do I need here? And can I get that other information? But that first step is, what else do I need? So in this case, drawing these pictures again, you should be able to tell that here we have a reflexive side. That's one of those freebies. We have a reflexive side. That's a freebie. We have a reflexive side. This one's a little bit hard to visualize. We've got kind of like these overlapping triangles. This one is ADC, and then this one over here is BCD. But this is the same side, DC, right? And these are marked congruent. So the question is, what other piece of information do you need for side, side, side? So I'll do side, side, side for all of these first. So for side, 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 I would need to know here that this side and this side are congruent. I would need that RK is congruent to TS. All right, notice how I wrote the order of those letters. RK, TS. That's the corresponding order if we were to write this congruent statement. Side, side, side for this one, I would need to have that AC is congruent to BD. I do not have that information, and sometimes that information gets a little bit clogged in here. Maybe folks are looking at these triangles instead of the big overlapping triangles, so you want to be careful that you're visualizing the right situation. All right? Over here, we would need to know that this one and this one are congruent. We would need XW congruent to ZW. All right? And if we have that information, then we would have triangles congruent by side, side, side. All right? For side angle side, I'll do this one in red, we would need to know that these alternate interior angles are congruent. So there's 2 ways for us to articulate that in this one. We could say angle RSK is congruent to angle TKS, or maybe if they just told us that RS was parallel to KT. All right, if they told us that these lines were parallel to each other, then yeah, these alternate interior angles would be congruent. Or if they just told us directly that the angles were congruent, that would be awesome. So sometimes there's maybe different ways for us to visualize that. Over here, if we wanted side angle side, we'd have to show that the big angle at D is congruent to the big angle at C. Now I've got to be careful because when I redrew this, I've got angle D and angle C, but that might get confusing, all right? So I need to make sure I'm using 3 letters here. I would need to know that angle ADC is congruent to angle BCD. BCD. Yep, come on in, you're good. And so you need this information here, all right? If you have this information, then you can say that you've got a pair of sides, pair of angles, pair of sides, and the angle included between the sides. And for this last one, kind of the same deal. We need these angles here around point Y to give us side, angle X, Y, W, and angle Z, Y, W. Okay. If you're able to identify what information you need, then it lets you power through your proof. All right, speaking of powering through, I want you to do this one. So you do this one. We will discuss it at the start of class next time. I'll read this to you so you know what it is that you are looking for. We've got that FG and KL are parallel. We also know that FG and KL are congruent. I want you to use that information to prove that these 2 triangles are congruent. Give it your best shot. And if you're able to do that, then I can say with confidence that you have learned how to use side angle side and or side 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 shortcuts to prove that triangles are congruent.